All right, welcome back. We are COMP2142, that's Game Artificial Intelligence 1 in the winter 2026 semester at Georgian, and it's week 3, part 2 of our broadcast. In the last part, we talked about dynamic steering behaviors, which are pretty cool, as well as we started into developing Seek, and yeah, absolutely, Logan. And then what we ended up doing was we started working on some of the, I'll say, supporting functions, to make Seek work. And so what we did was we came down here and I converted this to a pure function. And one question I just got, which is like, what's a pure function compared to a regular function? So let's go back and I'll show you. That's the best way to do it. If I was going to use our new function, get grid index from world coordinates, if I pull that in, you'll see that this is a green function. If I was to change it back, so this doesn't take any execution pins. I don't need an execution pin in here for me to get outputs. All I can do is get inputs and it'll give you outputs. No execution pin needed. However, instead of this, if I had it as a regular function, let's just go back and change this back to a regular function, compile and save, and then when I go back to my event graph, you can see that it's a blue function, and a blue function needs an execution pin. That's the difference between a pure function and a regular function. So why don't I want execution pins? Sometimes it's not required. Like, I don't need to have an execution pin to get an output. And also what ends up happening is it makes my execution flow more challenging. The only time I need execution pins is if I want to check certain things. Like, I want to do things like I need to do this first through this function first before I get to that other function, as an example. Like, I want the execution to stop and to absolutely flow through this one before I go forward. Otherwise, I can make this into a pure function. Pure functions are also great for little utilities like true false, pure function, as an example. I don't have to go through and make a branch, as an example. Sorry, I have to get that information and then branch from there. That's not as cool. I'd rather have, some kind of like utility function that only has outputs and inputs and no execution pins whatsoever. Here I have an execution pin in and an execution pin out, which is not something that I want. No problem. So back to this, I want to make this into a pure function. I can do that here, and that's what it would look like. Next, now that we have this, the next part is I want to do the other one. So I did a clear grid, but now I want to update the pawn. So the pawn itself, there's two parts of the intelligence of this whole thing. One part is the grid itself, and each cell is intelligent on its own, right? Each cell has information. And the other part, the intelligence of this part, is the pawn itself. We cannot go the other way around. The pawn knows where on the grid it is too. So they point to each other. There's a relationship there, as opposed to the pawn not knowing anything, right? The pawn knows stuff. And that's what I wanted to do. So what I want to do here is I wanted to take 3 inputs. A pawn, which is the base pawn itself, whatever that is, whether it's a start pawn or goal pawn or whatever. The snap location, we just created that, right? And the grid index, which we also just figured out. So I want to be able to do this update pawn function that takes those 2 things and then updates the pawn based on the world location and as well as the grid index. Let's talk about this. So back to this, make a new function. We'll call this function update pawn. The update pawn is going to take these 3 inputs. So pawn, here we go, which is of type base pawn, object reference. There we go. We also want to have a snap location. There we go, copy paste that. And that snap location is going to be of type vector, because we know it's going to be a location on the grid, and the grid index, all right, which is of type integer. So there's this one, and then we have integer here. There we go. So that's what we have in the update pawn. So the pawn is going to be updated with this information, right? So Now, assuming that the pawn is whatever it is, we need this little sequence node. And there's going to be two lines in the sequence node. The first line is going to be this, where we want to move the pawn to the world location. So this is like a set location thing. So pawn, I want to get the root component of the pawn. This is interesting. So I want to get the pawn's root component. So again, I can say get pawn, this one, and then get root component, right? I'm moving the root component, and I'm going to use the root component to set the world location. So set world location, there it is. And then once I have that world location, I want to set it to the snap coordinates. So this is the get snapped location, and I want to set it to that. So why? So again, remember what I'm doing is my snap location is a cleaned up location. It's almost like I look at a grid cell and I'm saying anywhere in that grid cell that I'm at, I've calculated that the center of that grid cell is where I'm going to snap this thing. That's what I'm doing with the snap location. It actually snaps the pawn right to the middle, the center of that grid. Remember, because I added the minimum and subtracted the minimum, and I kind of created this area where I can, kind of calculate the middle of that thing as well. I don't need to set up anything else there. So this is just move pawn to the world location. So move pawn to world location. That's what this does. Okay, and we can connect that up. So that's one part of it. We're moving the pawn. And the next part is going to be where I want to update the pawn's grid information. So that's the next part. So I want to, the pawn itself has a grid index, right, as an example too, right? So I'm going to say get pawn, this one, and then get set grid index. That's what I want to do. And I want to pass this grid index here. So get grid index, that's the local variable there, or the variable for the function, and pass that in. That's all this is going to do. So this is just updating the pawn's, grid index information. So I want to keep track of the grid index that the pawn is in. So again, set pawn's grid index info. Okay, we can use other things in there, but I think that's not bad. And I want to kind of do that. So that's what this function does. This function is pretty small, and all it does is those two things. And the reason why I want to use a function for this is because otherwise I'll be doing this over and over again. And I don't want that. Compile and save. So now that we have this, right, we can move on to something more complex. I want to update the grid location. So this isn't something else. So I'm updating the pawn. Now I'm going to update the grid. Think about this as, I could also have called this update cell, grid cell location, whatever it is, grid cell. And so I'm actually loading up the information on the grid cell, like what kind of pawn is on there, and all that kind of stuff. And so that's what I'm loading it. So this is a new function, and let's do that. And it has two inputs, pawn and grid index. So again, assuming that we have those two things. So pawn, again, is of type base pawn object reference, and then the grid location, which is the grid index, right? Grid index, and that's going to equal to an integer type. There we go, those two things. So we have those two things, and then what I want to say is, hey grid, I want to get the cell at that location. So get, and I want to get the cell at get grid index, this one. Okay, I want to get the cell. I'm getting the cell at that location of the grid index where the pawn is. That's what I'm doing. So access that cell or that element, and I want to break that. So break into its components, right, which is location, pawn, and state, right? And then what I want to do is I want to get the grid again, and I want to set the array element. So again, I want to get the grid, and I want to set the array element. Okay, so this is the opposite of me clearing it. This is me setting it. Okay, because I cleared it before, and now I'm setting it again. Okay, so here I'm going to get the grid index. So copy paste here. And then item, I want to split up again. So split struct pen. And where last time what we did was we left them clear, this time the pawn is going to be something that we're going to put there. So get pawn. So we're going to keep, so the cell is going to keep track of the pawn as well as the pawn's cell state. So again, I can kind of put this off. I could have done it differently. Get cell state, because the cell state of the pawn, remember there's only a few cell states. One of them is, I also like to think about this as pawn type, maybe. We could have called that pawn type instead of cell state. But really what it is this tells us, if we actually look at this enum, if you guys forgot what that is, let's go that back down to here. And if we look at the cell state, which is the enum, has these options: empty, start, goal, enemy, and patrol. By default, the cell state is empty, and then we can either have a start pawn, a goal pawn, an enemy pawn, or a patrol point. Right? Those are the options that we have, right? So what we're doing here is we're basically saying whatever this pawn is, whether it's a start or goal pawn or patrol point or an enemy, I want to set that, I want the cell itself to know what the pawn is. And that's what I'm doing here. Okay, so that's what this function's all about. Okay, compile and save. So this is the update grid location. So update pawn updates information on the pawn. The pawn itself holds information about the grid, right? Update grid holds information about the pawn, right? So they're, again, they talk to each other, right? And clear grid removes the information from the grid, right? We don't care about whatever pawn was there before. We're just removing everything, all knowledge of that because we've moved the pawn somehow, right? And again, these are all the pieces that we need to move my pawn from location A to location B, right? While keeping the grid informed, while keeping the pawn informed of where they are, okay? That's this part. Now, finally, let's get to that set pawn location function that I wanted in the first place. So set pawn location is going to use all that stuff we just made. So we can get rid of all that, and let's make that new function. Call that set pawn location. Set pawn location is actually going to do the move for us with all that stuff in mind. Updating the grid, updating the pawn, clearing it from where we moved to, all that stuff. So I need pawn and a location, right? So pawn is what we're going to put there. The pawn that I'm moving based on base pawn object reference. Now, if you don't know why I'm using base pawn object reference, because both pawns, right? If I go to pawns, both pawns, the goal pawn as well as the start pawn, derive from the base pawn. It could be either one or the other. And if I make an enemy pawn, it's going to also be a type base pawn because base pawn is the superclass of goal pawn and start pawn. Okay. So that's why I'm getting pawn. And then the other one is location. So location that I'm moving to, right? So, and the location is going to be location I'm moving the pawn to. So this is going to be a vector. There we go. And now that I have those two things, what I want to do, the first thing is get the grid index, snap location, and set the local variables. All right, so when I get the location, so again, what I need to do is use a sequence node. And I can see that there are 4 pins, or 5 pins here, 0 to 4, right? And again, I'm doing the sequence node instead of having like this long series of like connections and stuff like that. I'm just breaking it up this vertically. Now, in your mind, I'm hoping that someone will say at some point, wouldn't this have been easier in C++? And the answer is yes, it would have, because now we're doing stuff where it's this complex, where we may have thought about doing it in C++ instead. So first of all, let's get the location. So get location, this one. And once we've got the location, what we want to do is want to get the grid index from the world coordinates. So we want to use that really cool function we just made. There we go. Get grid index from world coordinates. Now we got the snap location and the grid index. And once we have that, we can save the snap location as a local variable. So promote to local variable. We'll call that snap location. There we go. Great thing about local variables is they disappear when the function is gone. They live and die inside of that context, right? So we can make them, and then we can, allocate memory and then deallocate memory once we go there. The next part is we want to save the grid index as well. So we save those two things. So promote to local variable, call this the grid index. There we go. Now some of you might say, like, why not just have that as a, if I keep doing this, why not just have it as a class variable? Problem is, it could be any pawn. And we don't want to pollute, you know, the class itself, the blueprint, with stuff that is only transient. We're going to have it now, and then we're not going to need it later, you know, kind of thing. So that's why we put it here. It's the same stuff over and over again, but that's what we're doing. Get grid index and snap location, set local variables. So that's what we're going to do. Get grid index and snapped location, and then set as local variables. So that's what we're doing. We're deriving that from the location parameter that we just used in the function. So we have the function parameter location, and we're deriving those two things. Snap location, which is a cleaned up location. Again, it could be the location could be anywhere in that cell, and it doesn't matter if I'm negative 1970. It's going to snap to the nearest cell. That's what it's going to do. That's why it's a snap location. And the grid index is going to be the index inside the grid, which is overlaying the actual world. Okay, you can't see it, but it's there. Next, I want to check if the grid index is outside of the grid index range. I don't want to be able to move my pawn by accident outside of the grid, because once I'm outside of the grid, it can cause all kinds of index out of range errors. So this is a preventative step that I'm using to stop that from happening. So I'm going to say, okay, well, hey, grid index. If my grid index is greater than the grid length, right? So is greater than. Now here's something. Grid index is going to be from 0 to the, you know, the grid number. If it's greater than the grid itself, grid, get grid, and then length, right? If it's outside the grid length, that's bad. That means that somehow I'm indexed out of range. That's what's happening right now. Okay? I'm not looping, so this is okay. If I was looping, it would be greater than or equal to. Okay? If that's true, or if the grid index is less than 0 somehow, that's the other option. So that if this is outside the upper bounds, or if this is less than the lower bounds of the grid, less than 0, right? And by the way, notice I'm not using a number. Like grid index right now is like, maximum grid index is like 1599. There's 1600 elements, 40 by 40. But what if in the future we want to make a much larger grid or a much smaller grid? So I don't want to hard code it here. I want to use numbers that are, you know, that are calculated from the length. So either one is an or. I can use an or Boolean here. So either condition is true. That means there's a problem. If it's outside the bounds, greater bound, the greater end, the maximum value of the bounds, or lower bounds, right? Upper bounds, lower bounds. If it's greater than one of those, or less than one of those, then branch return out. We don't want to do this. We don't want to we want to stop the movement from happening, right? If that's true. And we can use a return node for this. Add return node, which is basically just saying return. That's what this does. It kind of early exits out of this function, right? Which is what we want to be able to do if these conditions are satisfied, which is like we've gone out of range. Okay, so that's what this does. We want to check if the grid index is out of range. So check if grid index is out of range. If so, return. Okay, because we want to early exit out of this function, because that would be a bad situation. It could cause us to have an index out of range error or other problems, like all kinds of like null reference errors in the future. Okay, so that's what this does. Next, what we want to do is, once we have that, we want to use each of our previous functions used to compose this part, which is I want to get the pawn. I want to clear the current location from the pawn. That's the next one. So I want to get the pawn. So the pawn is this, right? So get pawn. And I want to use our clear grid location from the pawn. So that's the first thing I want to do, right? So that's what I want to do there. And what this does is it clears current cell. So this is like when I'm moving, that's what this would do. So wherever the pawn is right now, clear it up. Even if the pawn wasn't anywhere, clear it up anyway, whatever the pawn is. So that's what it would be. So clear current grid location. Clear the pawn's current grid location. That's what that is. And that just clears information that's being kept there about the pawn. The other one next is I want to update the pawn. So again, we're using all the pawn stuff now. So here's the pawn, and I want to update the pawn. There it is. So update pawn. I'm going to grab that, put it in there, and get myself a rewrite node. And it needs snap location and grid index, which we have. So there's my snap location, and there's my grid index. Let's do that. So get snapped location. That's a local variable. And then get grid index. That's also a local variable, right? And if you look down here, that's what we have here. We have snapped location and grid index and local variables, and we're just using these to update the pawn location and index, which is what we're doing here. So update pawn location and index. So what this does is it actually moves the pawn. This moves the pawn's location. It changes the location of the pawn. This actually does the move and updates its grid index in the you know, kind of on the grid. Right? So this is actually the thing that does the move. So the beautiful thing about doing a return like this is if it doesn't meet the criteria, if it's outside of range, we never move anything. We don't do this part stuff. We don't clear the grid. We don't do nothing. The pawn stays where it is. Next, I want to update the grid location. So again, I'm going to get the pawn, right? And I want to update the grid location. So here's update grid location. And we're just going to do that there. So that does this part. Update grid location. Okay. And of course, the grid location also needs a grid index. So I'm going to copy that and put that there. And that's what this is, update the grid location. Update pawn's grid location with information. Right, the pawn's info, like what it is, you know, all that kind of stuff. Pawn state, cell state, blah, blah, blah. And this, finally, all this stuff that we did, I'm just going to make this a little nicer so they're all the same, these ones. This one, this function, that's why it took us long to make this thing, is I'm making it because it has all the checks involved. We're checking to see, it's not just simply moving something. It won't allow us to move it unless we have something that we snapped into. That's number one. We can use this also for autonomous movement, not just me clicking on it. So it's going to stop me from going out of range and those kind of things. As well as it'll keep track of cells as we move things. All right. So this function, and let's make this a little nicer. Let's move this so it's just down here. Looks nicer. This is our thing we want to save, which is set pawn location. So file, save all. And we're going to put this up on DevOps. Git add dot. Git commit -m. We'll say added set pawn location function, and that took us a while to get to, but it's a key function that we're going to use over and over again, as you'll see. Now that we have that, and which is great, we have this thing. We don't need this anymore. We haven't tested any of this stuff out, and this is the thing we should test soon, because again, there might be some issues. Right? But the next part is to actually use this function, and the place to use it is in place of what we did previously. So let's do that first. So back to the event graph, right here, we did set actor location for the start pawn or the goal pawn. We don't want that anymore, and we don't want any of this check. We do want the cell locations, those things we keep, but all of this stuff can go. So goodbye, all that stuff. Yay. Now, we don't want to trigger it, we want to start it, and we want to use the set pawn location here. So here we want to get the start pawn. Here's a reference to the start pawn, and here is reference to the goal pawn because we want to move those things. And then from there, we want to set the pawn location. So set pawn location, there we are. And we can use the location here, which is world coordinates, wherever we're snapping to. And we want to use the started execution pin, because we don't want to use trigger. Trigger means that we would just hold down things. And let's make these a little bit closer to this. And so now what we have is something that looks like this, right? Which has all of our checks and balances in there compared to what we had before. Okay. Similarly, we can do the same thing, copy paste, because the same function that we're just using again, and this time now, beautifully, we're going to connect it to the right mouse button. So this is the left mouse button, this is the right mouse button. Yay. All right, and we'll do some commenting. Move start pawn when left clicking at grid location. So move start pawn when left clicking on grid location. That's what that is. And I like that. And we can make this a little tighter as well. Something like that looks like this. There we go. And then move goal pawn when right clicking on grid location. That's what that is. So right click moves the goal pawn, left click moves the start pawn. So far. And those two things allow us to move things around. Let's try this and see what happens. Compile and save. And if I was to run it, hopefully it's not going to crash, right? So if I left click, it'll move things just like before. Right click will move things as before. But, and this is a beautiful thing, the grid character will know all kinds of information about both pawns. So let's take a look at those and then do an inspection. So now we're going to test. So we know that we have the grid. Here's the grid, right? And the grid is full of these things, right? So each of the pawns in the grid, so if I go to the start pawn, here it is, the start pawns has some information about the grid itself, right? So here's the start pawn. And one thing that it should have is things like the grid index and all that stuff. So if I kind of look at grid index, if I type in grid, right? Here's my grid index, 811. That's pretty cool. 811 is my grid index for my start pawn. That's this one right here, right? And let's see if that computes with the grid. So does the grid say the same thing? So if I look at index 811, does it show the start pawn? That's important to note. So if I go back to my my grid character, and if I look at the index 811, so if I zoom down there, if I actually just type in 811, right? Then here's 811, and take a look. It says BP underscore start pawn, right? And it should be at -850 and 50. Okay, it also has a 0 index because we're 0 on the z-axis right now. We don't care about that. We're not tracking that, but we know that it says it's the start pawn. Okay, so that's what it says. Well, let's see if that's true. If I go back to the start pawn, will this give me -850 and 50 as x and y coordinates, right? So remember, this is the x coordinates, right? -850 and 50 is the y coordinates. Does that make sense? So let's see. So if I go to the start pawn, and now if I do this, it says -850 and 50. So it has that information. So it goes both ways. Both of them point at each other, which is exactly what we wanted, my friends. Right now, here's the trick. If I move the start pawn from here to here, and if I still look at 811, it should be cleared now. Let's try this out. That's the next part. So if I go back to the grid character, and if I look at 811, then it should be clear, and that's what it says. 811 tells us it's -850 and 50, but there's no pawn there. It's been removed, and the state is empty. We've done what we wanted to do. This is a good test. Do you understand what I've done? So both things, just say it again, both things, the cell and the pawn, have information about each other, which is a very key thing for us, because once we have that information, it's valuable information we can use to do calculations in the future. Right now, you can't know why we would need that, but in the future, I want you to think about it. I have information about what cell I'm in, and the cell has information about what pawn's in it. Okay? So it goes the same way for the right, right and left. One thing I also want to do, not just left clicking and right clicking, that's one really cool thing to do, but what I also want to do, get rid of this, is I also want to preset the starting locations for my pawns, right? So right now I randomly put them, like I literally manually move them, but I want them to snap in place. So a good example of that is to test this. Let's just put these things like something in the middle like this, okay? And I'll put this one somewhere in the middle of two things, like 4 squares, like this. Okay, this is kind of like in the vertex. This is not correct. This can't work because these 2 pawns that I've put in the scene are not snapped to any location. Let's snap them to the location that I want them to be in, right? So in order for me to affect this, then what I want to do is I want to, in the event begin play, I want to put them in those 2 locations. And I can do that now with set pawn location, right? So let's do that. So back to this, and right here, and I'm just going to zoom out a little bit so I can move this down just to give myself some more room. And in here, I can get a reference to the start pawn and the goal pawn, and I can use this same function, set pawn location, for both of them. Here it is, right? And for the start pawn, we want to put it at -550 and -150. So we can just type that in, -550 and -150. Why is this good? Because now we have ultimate control. If I want to move something in a specific spot, I could actually allocate the entire cells. I could put walls and stuff and whatever I want in here, other obstacles, because now I can move any pawn, whether it's a start pawn, goal pawn, some kind of barricade, whatever I want in my level. I can start building it up, and I can do it programmatically, which is pretty cool for me. All right, so there it is. And now -550 and 150. This is the same location. We don't want them to be in the same location. This should be like -550 and -150. This is actually wrong. This should be -550 and +150. So this is actually, be careful about this. This is going to be in the same spot. Oh, wait. No. I was the other way around. This is -550 and this is +550. I'll be all right. This will be actually, it's a good test to have, right? If I did this, here, this is actually a really good test. I'll do something that the PowerPoint doesn't say, and it'll look different if I press play. You'll see that they're in a different spot, but they're also snapped in there, right? So if I click on these things, if I click on the start pawn, you can see that it is a -550 and 150, and the goal pawn is at 550 and 150. That's not exactly what I want, but it actually proves to you that even if they're offset like this, when I start the game, it moves them to where I want them to be, which is a snap location that I've decided what it's going to be. So back to this, let's just change that to what it's supposed to be. This is -550 and -150. And then if I press play, compile and save, then they're going to be right next to each other here. All right, so no matter where I move it, they're going to be there. Let's try that again. So it's way out here, but if I move it here, you can see that they're right next to each other. Questions around this? All right, is this clear what I'm trying to do? Hopefully it is. All right, file, save all. That's important to do. And now that we have this, I mean, I've monkeyed around with these things, but we can put them in somewhat the correct places. 550 and -150. And wait, is that the right one? No. Yeah, and this is yeah, -550 and -150. There we go. So that's where it's going to be eventually, like this. It's going to look like this, right? So I'm just putting them in there anyway. So that's what we had before, so that we don't have to necessarily move them if you don't want to. All right. So now that we have this stuff, now we can actually start working on seek behavior. Okay, we have it's 3 o'clock. We still got some time. And I want to work on this for the next 10 slides. Okay, it's 10 slides to do seek behavior. I swear to God. All right, let's move on to the first one. So the first one is I want to again, this is prep. I always kind of do prep first. is I want to calculate my angle to direction. So this is actually going to return a angle in degrees, because I want to say, well, what angle do I have to move? What's my angle do I have to go to? Is it like 50 degrees? How much do I have to turn is what this is. So that's the first part. So I'm going to go back to this, and I'm going to add a function. And by the way, we're going to fix these functions up eventually. But for now, this is the first one. Calculate angle to direction. I'm going to take the desired direction as a vector. So desired direction. There we go. And then inside there, I'm going to get the start pawn, and I'm going to get the forward vector from the start pawn and save that as a forward vector. So start pawn, and then get forward vector, right? Now it says get forward vector from my spaceship mesh, right? That's right, it does that. And that's definitely something I could do, but that's not what I want to do. I don't want to get the forward vector from the spaceship mesh. I want to get the forward vector from my default scene route, right? Now here's something that is something that you're going to see. Notice that this doesn't have that. Well, because I'm getting the forward vector, getting the actor forward vector is what I want, right? So let's try that again. Get actor forward vector. Now I don't have to have that anymore, right? And once I have that, I can save this as the forward vector. So promote as local variable forward vector. There we are. And then once I've done that, then this one is going to be save the forward vector, save forward vector. Okay. And here we go. And that's the first thing I'm going to do here. I want to break this into a sequence node. Okay, so we can do that. Here's my sequence node. And then I need another pin there for that. And I want to get the dot product to check if the target is behind the pawn, because dot product will check where it is, right? Is it behind the pawn or is it in front of the pawn? So I want to get the desired direction and the forward vector and use the dot product. All right, so desired direction, get desired direction, get forward vector, this one. And I want to use a dot product, and the dot product will give me a very special value, right? So this will be, you know, kind of like I could take two 3D vectors, and then it's going to give me the dot product, and the dot product I can clamp, right? So I can use the clamp function, clamp float. Here it is. And the clamp float function I'm going to use is between -1 and 1. So I never want it to go be more than -1 and 1. If it's negative, it's behind me. If it's positive, it's in front of me, right? So that's what it is, okay? And then I want to save that as a local variable. Call this dot product, so we don't have to recalculate that later on. There we go. And we don't have to draw long wires. So this is get dot product, check if the target's behind the pawn. Let's call this get and save dot product. How about that? But that's what we're doing it. We're doing it because we want to check to see where, if I'm rotating, which is what I'm trying to do. I'm trying to get the angle. What's the angle? Is it a positive angle or a negative angle? If it's a positive angle, it's in front of me. Negative angle, it's behind me, right? As an example. And then I want to take the dot product. Right now it's in radians, and I want to use the arc cos, and it's going to give me the angle, right? So again, get the dot product, and then use arc cos, a cosine, right? And it's going to give me a cosine in radians, right? And I want to convert from radians to degrees. So R2D is what I use. R2D, radians to degrees. So it gives me the degree conversion, right? And then I want to return this out as the angle. So I'm going to say add return node. And it's a bit of math, but it's okay. And then we're going to call this, instead of return value, this is going to be the angle that I'm going to get back out. Okay? So this is what we want from this function, which is the first function we're going to use because we want to rotate our pawn. We want to look where we're going, right, as one of the steering behaviors. And we want to return the angle. So return angle. Now again, if you don't remember the math, it's okay. I've done it for you. But this is kind of one of the things that we need to do. I want to calculate the angle to the direction. So we've been given a vector, and I want to, whatever that vector is, that's the desired direction I want to go to. What's the angle to that from my current vector? That's what I'm calculating. Compile and save. All right, and that's the start pawn. The reason why I'm putting start pawn in there and I'm not getting the goal pawn is the goal pawn is not going to move. It's the start pawn that's going to move. Otherwise, if I wanted any pawn to do this, then I would input a pawn as well. Here, I'm not doing that. I'm assuming that the start pawn is the only one that has to be the one it's going to be. I know, I'm so sorry, Vincent. It's pretty crazy. Compile and save. All right, so now that we have the calculate angle function, which is pretty cool, the next part is going to be, yes, six pins, rotate towards, okay? And it is what it is, my friends. So rotate towards is the new function, and we're also going to take the desired direction in there. So I'm going to get new function, rotate towards. I want to get the desired direction as a vector, desired direction, and it's a vector, yay. And the desired direction, I want to save the current rotation and forward vector. So start pawn, get actor rotation. So start pawn, get actor rotation, right? And I want to save that as current rotation. So I want to promote to local variable, current rotation. So this is where I'm looking, almost like the orientation of the start pawn itself. And then I want to get the start pawn, the forward vector. That's important too. So get actor forward vector, right? And I want to save that as the forward vector. So promote to local variable, and we'll call this forward vector. So now I have those two things, the current rotation and forward vector, and I want to save those two things as the stuff I want. And I'm going to call this save current rotation and forward vector. So save current rotation and forward vector. Okay. And once I have that, I want to definitely use a sequence node with a bunch of pins, just like Vincent just said. And now there should be some part of you deep inside that's saying, isn't there, can we have done this with C++? If there isn't, you'll get there. Okay, compute angle to desired. I need the desired direction. Get desired direction. And I want to calculate angle to direction, that thing I just made, which is this one. Calculate angle to direction, right? So this is going to give us my angle. And it's going to be an angle in degrees. I need to make this into a pure function, because I forgot to do that. There's my pure function. And then I want to save the angle to direction. So promote to local variable, angle to direction. That's what that is. And then what I can do from there is I can connect it there. Right? And that's what I'm saving. Compute angle to direction. Compute angle to direction. And then from here, I can do one of those. And now we're a lot better. And the next thing I want to do is a couple things. Compute the cross product to determine the direction of rotation. So I know it's behind me. It's not in front of me. I can compute which one. Is it to the right or to the left? That's what cross product does now. So I need the forward vector in a desired location. So forward vector, get forward vector. And also get the desired location. And you can use the cross product for this. Cross product and dot product are like two of the most useful functions you can use. And here I'll just save this as cross product, right? So I don't have to pull pins for this. Okay, so this is compute cross product to determine direction of rotation. Compute cross product to determine rotation of direction of rotation. Direction of rotation. And hopefully you guys have done like all this stuff with when you did math. And then if the cross product dot z is greater than 0, then rotate to the right, otherwise rotate to the left. That's what it does. So if it's greater than 0, rotate to the right. Less than 0, rotate to the left. All right, so we want to get the cross product and break it, break vector. And we break the vector, we want to just get the z, and we can compare that. So if it's greater than 0, that's what that is, branch. This is a test for the cross product, right? So once we get the cross product, we need to test it, right? So that way it's we can use it. Otherwise, cross product doesn't do anything as we do something with it. So positive is set rotation direction. Now this is two local variables. We have to set up one local variable called rotation direction, right? So let's set that up. So rotation direction. Set this up as a local variable, and I'll make it float, right? And then I can set the rotation direction, if it's true, to +1, or I can set the rotation direction to -1, and that's going to be something I'm going to multiply later on. So if it's positive or negative, right? I know lots of calculations here for rotate towards. And this is if cross product z, right? So if cross product dot z is greater than 0, then rotate right, and rotate right, otherwise rotate left. And that's what the reasoning is for this whole thing, so you understand why I've done this. And next, what I want to do is I want to compute the rotation step. So the rotation step is how much I want to rotate every frame, right? And that's based on the rotation rate. Let's make a rotation rate variable that is not a local variable, but a variable, a class variable. So I'm going to take the rotation rate first and make that into a class variable. So that's up here. So we'll call this rotation rate, right? And compile and save. Let's set that rotation rate to 45 degrees. So the maximum we can move starting off is 45 degrees at a time. Okay, that might be too much. Maybe eventually we might tune that a little bit and make it 30 degrees, or increase that to 50 degrees, you know, as an example. In engine and math, that's too bad. Well, that's okay. We're doing it now. So I want to get the rotation rate and the angle to direction we saved, and I want to get the minimum value of that. So rotation rate and angle to direction, here it is. And now that we have both those things, I want to get the min of those two things, minimum. And the min basically returns which is the minimum, the rotation rate or the angle to direction. Why? Because if the rotation rate's 45 but the angle to direction is only 22, I don't want to go 45, I want to go 22, right? So that's what this does. Then once I have that, I want to multiply that by the rotation direction. So I want to multiply that by the rotation direction, which is positive or negative, right? Because that's where we know we're going to turn right or left. Is it to the right or is it to the left, right? If it's to the right, we turn positive whatever, or if it's to the left, negative whatever, right? That's what this does. And then after we've done this, you know, as an example, then we set that as a rotation step. So we're going to set this as a local variable, call this rotation step. So that frame, it's going to move that many degrees in whatever the direction it's going to be. So this is compute rotation step. Let's put another one of these and move these down here. And we'll say compute rotation step. Now, I know I've had criticism in the past when I've done all this stuff. They're like, can't we do this simpler? Can we not even use the grid at all? You're right. They don't have to use the grid at all. But there's a reason why I'm doing the grid, because next half of semester we're going to use the grid the entire time, right? So might as well use this now. Again, pay it forward. Current rotation is what I want to do. Is I'm going to take the current rotation and save a temporary variable called new rotation, right? So I'm just copying it. I'm making a temporary variable. So so new rotation. So current rotation. Here it is. And I want to promote this to a local variable called new rotation, right? So all I'm doing is saving it for a second, right? That's what I'm doing here. And once I've got the new rotation, then I want to break that new rotation down into its piece parts, right? So when I get the new rotation, and I want to split the struct pin into its piece parts. So roll, pitch, and yaw, because remember this is a rotator, it's not a vector. And then what I want to do is take the yaw and add it to the rotation step. So whatever I'm looking at, I want to add it to the rotation step. So the rotation step we just calculated, I'm going to add that angle to the yaw, whatever this is currently, of the current rotation, right? And then what I want to do is I want to set the new rotation. So set new rotation. And again, I'm going to split the struct pin here. And I'm going to just do this part. And I'm not going to change the new rotation there. So that's going to be this. All this does is it cleans up my my rotation. And all I'm doing is I'm using the z-axis, the z component, which is the thing that I'm modifying. Okay. And then since I'm only modifying this and I'm not doing anything else, then what I can do is I can set the actor rotation to, there's no rotation on the X and Y. I'm not rotating on the X and Y. That means I would flip it this way. It's going to be 0, right? I'm only rotating on the Z, right? So I'm going to set the actor rotation for the start pawn. So start pawn. And then set actor rotation. This is where I'm actually rotating it to the new rotation, right? This is what that is going to be, right? Because the new rotation, actually, I can just get it from here, the new rotation, but I could have also dragged like I did. So that is what I'm doing, and let's clean this up because it's way too spread out. So first of all, let's bring this in a little bit, and we'll bring this in. Then we'll bring all these in, and then this whole thing is a line, and we can say that this one is apply rotation step and rotate the start pawn. Apply rotation step and rotate the start pawn. So I'm only rotating the start pawn because, again, I'm not rotating the gold pawn. The gold pawn is not moving. It's only the start pawn that's moving, so I'm only affecting this. Again, if I wanted to rotate any pawn, I can just take in pawn inside here and then, use that instead. Compile and save. And last part for this one is return the pawn's new normalized forward vector, because if I have the forward vector, I can use that in the next thing that I'm going to do. So start pawn, whatever that new forward vector is. Let's try to get that again. I want to get the root component, get root component, and I want to get the forward vector, get forward vector from the root component. There we go. And once I get that, I want to normalize. So normalize is actually a really cool function that's built in to here. It's just a function we can call. We don't have to do the division and all that stuff. It just does it all for us, which is cool. And I want to save this as in the return node. So add return node. Oh. Add return node, this one. And I want to pull that out. And I'm going to just connect this up here for now. And let's try that again. This there. And move this down. And this one is return the pawn's new normalized forward vector. So this is going to be called new direction, new direction. So the desired direction, this is the new direction I got to go in, this frame. Okay, so that's what this is going to return. Return the pawn's new normalized forward vector. Return the pawn's new normalized forward vector. Because that's the new direction that we want to use, because that's the direction we're going to use this frame. So this step, this movement step. Because remember, we're not going to move all of our movement all at once. We're going to move like a board game piece, one step at a time, right? That's the challenge about using this thing. So there's a couple of things I've asked you to do. One thing is to use the grid, and the other one is to move step by step. This is a good one to put up on DevOps. So compile and save. Let's put the rotate towards on DevOps, right? So again, back to here, git add dot, git commit -m, we'll say added rotate towards. Okay. So once we have our rotate towards function, now we can build on that, and we can steer towards the goal. We can use move to target, and we're going to use the rotate towards every step, right? So that's what the move to target method is. So copy that, and I want to make a new function, which is going to be called move to target. And again, we'll clean up all this later. Move to target is going to have two things, a current location and a direction. So current location and a direction. Okay, so current location, direction. I want to take the direction and I want to rotate towards that direction. So I want to use the rotate towards, do this. Okay, so rotate towards, and then let's just do one of these. So get direction, instead of me combining it, we'll separate it because I don't like to draw lines, and if I don't have to. And then the next part is I want to use the speed. Now we don't have a speed variable, so let's add a speed variable. We'll use the speed about 150 in terms of units. So again, that'll be a variable, not a local variable. Speed, compile and save. We'll add a speed of 150. That's 150 units per. Notice the number, 150. It's in increments of 50. The cell size is 100, and if we move 150, it'll be the next cell. Okay, the next cell over in a bit. Okay, which is what we want. So that is, I'm going to take the new direction, multiply it by speed. The direction, remember, is a unit vector, is what we're going to get, right? And multiply it by speed. That's what we're going to get, and that's going to be the next step. I'm going to move in that direction. Okay, and then I want to add that to my current location. So I want to add to my current location, get current location, right? So I'm going to add that into my current location. So wherever I am, my current vector, I'm going to add my new vector that I'm computing based on where I'm rotating towards that step. Okay, that's what I'm doing. And then once I have that, then I want to set my pawn location. There's that function again, right? So set pawn location, right? And what pawn do I want to set? The start pawn. So start pawn, right? And the location is going to be this thing I just computed from here. So that, my friends, is going to do two things. It's going to rotate me and set my pawn in that new location. Rotate, step forward, and set my pawn. Rotate, step forward, set my new pawn. Rotate, step forward, move my new pawn. And so this does all the calculations for the new location, right? And this actually moves the pawn to that location, updates the grid, updates the pawn based on the grid, removes the stuff, like do all that stuff we just did earlier. Okay? And this is steer towards the goal. So steer towards the goal, right? That's what it's going to be. And that's all this does. All right, so compile and save. And that's called move to target. All right, now that we have that, we can finally do our seek function. And we have 3:43, we still have time. We're going to make it. It's a bit of a speed run today. So first, let's make a new function called seek. New function. Call this seek. So this is our actual seek algorithm now, finally, after all this. We need a sequence node, and we need a few pins. There we go. And then the first thing is, let's get the current location and let's get the target location. So, so for this, we need the start pawn. And the start pawn, we're going to get the root component, get root component. And what we want from there is get the world location, get world location. So this is a clean world location using the root component of the start pawn. And once we've done that, we want to save this as current location. So promote to local variable, save as current location, right? And that's what we want to do for this step. So this is our starting location, if you will. So get current location, get current location. That's what this does. And then once we have our current location, we want to get the desired, the target location, right? So, so we're going to get our goal pawn. This is where we're going to actually use our goal pawn, get the root component, right? The root component is going to give us our world location, get world location. And then from there, we want to save this as the target location. So promote to local variable, target location. Right, so that's what we need there. We need the where we are and where we want to go. We can also call this the desired location, but that's fine. So get target location. Okay, like so. And actually, we'll do the other way around. Move this part this way, and we'll move this part this way to make them kind of the same size. So that they're not completely ugly. There we go. And then once we've done that, once we get those two things, now we're going to set the normalized direction to the target. So target location minus current location. That's right from the formula that I gave you guys when it comes to computing our direction. I'm going to take the target direction, subtract the current direction. That means I'm going to look in that direction. So you know, that means get target location, get current location, right? Target location minus current location gives us the complete vector minus, right? We don't want the complete vector, we just want the unit vector, right? And so we normalize. Normalization gives us the unit vector, that's the desired direction, and that's what we want to save. So we want to promote to local variable, and we'll call this the direction, right? That's the direction we want. So the target location is where we want to go, but this is the direction that we want to go to from where we are. So from where we are to where we want to go, that's the direction. So this is set normalized direction to target. And we'll change that to black. And then once we have that, right? Once we have the direction, right? Then it's very simple. Move towards target. So we can use the current location, right? And the direction where we want to move to, and we can move to target, which is what we made earlier. Move to target, right? Where we plug in the direction and the current location. So this is all of our hard work that we've just done this entire day, you know, kind of realized when we do this. There we go. So this is move towards the target. Move towards. It's not just move though, right? It's actually move and so rotate and move. It's actually rotate and move towards the target, because if it was just move and no rotation, then that's fine. By the way, we can test that if you really wanted to just rotate or just move, we could break those down, because move to target, if you recall, right, has the rotate step as well as the new location step. We don't have to do the rotation step at all. Remember, all we need to do is take the speed that we want to do and add it to the current direction, and then we keep going in that direction, right? And then set the pawn. So the current location is what we're adding things to. Rotate basically tells the direction that we want to rotate in. But I'm doing two things in my rotate towards function. It's very complex, but what I can do is, instead of physically rotating, I can just give myself a direction. I don't have to do the rotation step at all. I can undo that. I can uncheck this, right? The only thing I care about is the new direction. Once I've got that new direction, that's all I need, and so I can move without looking where I'm going if I undo this step, right? What I'm actually doing is not only rotating, but I'm also looking where I'm going as I'm moving, right? Which is important. All right, so that is what this does. This is our seek algorithm, and it's way simpler when you look at it like this. Well, why? We did all the heavy lifting in here. Move to target actually does most of what we want to do, right? It just depends on which target we give it, right? And this is the key for what I'm going to ask you guys to do from a challenge perspective, right? All right, so compile and save, and let's put this up on DevOps. So git add dot, git commit -m, we'll say added seek algorithm. Okay, git push. There's our seek algorithm. But now we got to use it. And this is the last thing that we want to do for today. So how do we use the seek algorithm now that we have it? Well, we need a couple of things to do this, right? One is we need some kind of input. So let's add a seek input. So back to this. I want to go into my input action, and I want to add a new input action to test this, IA seek, so we're going to call it. And then we also want to add in a new mapping, which will use the seek mapping, and we'll use the E key. When I press E, the one key, I think that was what I asked you to do on your assignment, rotate seeks. And if I press 1 over and over again, I should be able to toggle on and off the seek algorithm. Okay, so that's what I'm doing. So save this. There we go. And now that I have an input, I can do IA seek. There's the seek algorithm right there that I want to use. But I want to use a timer in order for me to do things step by step. I want to move things in a step-by-step fashion. I'm almost done, guys. I'm so sorry. So what do? I'm going to make a new function. I know, by the way, last time I did this, I had someone call me function queen. You're a function queen, Tom. You just keep on adding more functions. You're right. I am. I fully admit that this is what I am. All right, there we go. I don't know why they didn't call me king, but that's fine. So here it is. There's toggle behavior, and then there's my behavior. Behavior is a name, right? So again, if I go here and I look at, I believe it's name. Here's behavior. And I can make this a name. Is it name or is it a text? What does that look like again? Oh, we'll know in a second. So is timer active? I need to add this new Boolean as well as step delay. So let's add those two things. And this will be a variable, not a local variable. So is timer active? That's going to be Boolean. And compile and save. It's by now the timer starts off as inactive. And then I want a step delay, and I want to use 0.25 as a standard value, but we can change the step delay later on. So 0.25 for step delay. So make that a floating point number. And again, I'm just arbitrarily giving a number right now, but later on we're going to make a little user interface that allows me to change the step delay, right? So that's what I've got there. Now that I've got my is timer active, I can pull that in and check to see if it's true. So if the timer is active, if it's true, what do I want to do? I want to, and if I press the button, that's what this happens. So my timer is active, I press the button, I want to stop the timer. So what I can do is I take that behavior and I can say pause timer by function name. So we'll do that. So I'll say pause timer by function name. And is this a name? Did I make this a name? I did. That's good. Oh no, is it a string? That's a string. Sorry, that's a string. So we'll change this to string. Sorry about that. That makes more sense. And then we'll take that behavior, get behavior. Now I call it behavior because we can use this for anything. If I want to do seek behavior or arrive behavior or whatever behavior, I can use this same step-by-step function that allows me to start and stop the timer. That's what this does. So this is not going to stop the timer. It's just going to pause the timer, right? So that I can, like, restart it later. All right, so that's this part. And then I want to say that is timer active. Let's set that. Is timer active? I'm going to set it to false because we've just stopped the timer. So if this is true, make it false. That's why it's called toggle behavior. If it's false, then we want to make it to true. Take that behavior and the step delay, and we want to set the timer by function name. So set timer by function name. There we go. And I want to take that behavior, that's the function name. There we go. And the time is the step delay. And looping is set to true. That's important to do. And then is timer active is going to check on to true. So that way when we check this again, it'll check to see if the timer is active and go through this whole step. So this is a little toggle that allows us to turn off and on the timer, as an example, every single time. Compile and save. All right, so that's toggle behavior. So now that we have our toggle behavior, we can use it here inside of our IASeek. So let's try that. So I'll say toggle behavior, and not triggered, but rather on start. And the behavior that we want to use is seek. And this, my friends, is our seek function. So this is seek steering behavior right here. Seek steering behavior. So the key thing here that I want you guys to take from this is that I don't want to call the seek function directly when I click this, right? Because if I call it directly, I have no control whether to stop it or not. So in the future, when we have a user interface to do that, like a button to start and stop stuff, I want to be able to do this in a way that I can start and stop the seek behavior as I go. This is a perfect time to test this out. Let's see if I did something right or if it broke. It could be broken. I don't know. I've never tested this yet. And if I'm here, let's put this way down here. And if I press the 1 key, then you can see that it seeks to the goal and it keeps on going in circles. And this is the behavior you should see, guys. Okay. And notice it goes through the goal, but it keeps going because we don't have, it doesn't stop. It just keeps going there over and over again. If I move the goal, like over here, it'll seek to that goal again. It'll keep seeking. So I'll move it over there. It'll keep seeking over there. Over here, it'll keep seeking over there. Now, here's the challenge. The challenge is when the goal is here, like on the edge. Let's see what happens if I put the goal on the edge, like up here. What's it going to do? It's going to skim by and do weird stuff like this. See how that it went outside of the thing there? That's something we wanted to prevent. Now, that might cause us, because it's outside of the grid, it's not supposed to do that. It's supposed to actually skim along the grid, not supposed to go outside the grid. So let's see if we stop it. Do we get any errors? No, we didn't. That's good. But it's not supposed to do that because there is no grid there. So how did it do that weird step? It followed the move to. It followed the move to over and over again because it's like, hey, that's wrong. So I'm going to fix that up next week. But I want to show you that. Didn't quite work exactly as I wanted. Let's try this again. And let's try so that the thing is on the other side. So if I put this way and I put this one over here and if I press 1, then it should just turn and go to that direction. And not bad. Not bad. Oh, it goes outside the thing again. So that's something I didn't want. But it sticks within the grid and it kind of rotates towards. So I move over here, it's going to go down there. And if up here, it's going to go up there. And down here, it's going to go down here. And it's going to keep on following this thing no matter where it is. It's going to keep turning in that 45 degrees manner over and over again until it finds the goal. So this is our first iteration of Seek. It's not bad. It works great. And it's a good thing. It's part of your in-class exercise, your assignment 1A. This is one part of your assignment 1A. Now, your challenge, my friends, because I've done some of it. Your challenge is code the flee steering behavior. If I've got Seek, right, and flee is the opposite of Seek, how would you code flee? And how would I incorporate that? What are the steps I need to incorporate, to make flee work? Well, I said in your assignment, I think it's 2 for flee, if I'm not wrong, right? So you need to have some kind of input. Here's the thing you need to do. You can see here exactly what it's doing. It's kind of seeking to, and it's going to keep on circling around over and over again. So we need to do that. You need to have a separate algorithm for flee, but the guts of seek is part of the stuff you need for flee, right? So I need you to look at the documentation I gave you. I gave you the actual algorithm for flee. I gave it to you. It's in the PowerPoint from last week, right? So and there's a bit of a difference between seek and flee. Take a look at it and see if you can implement flee. What flee does is it'll keep on going away from the target. So if I put, like, like the way to test this would be, okay, well, here is my start pawn, and I put my goal pawn next to it. It should go the exact opposite direction. It should just like get out of there, right? If it's right next to each other. All right, that's how flee should work, and it should go like way out and the opposite direction of where it is. And if you move your goal pawn, in front of where it's supposed to be, it's going to go the other way. It's going to keep on running away from wherever the goal pawn is. If you try almost like trap your spaceship with the goal pawn, okay? So try that out. And then the more difficult one, which we're going to work together on next week, is arrive. So it is seek. That's what arrive is. But as you get closer, if seek is selected, it's going to slow down, and stop right on top of the goal. Okay, so that is what we're doing. We're almost there for assignment 1A, and again, there's some parts for you to do for next week. Questions before we go for the day? I've given you everything. I'm going to put this up on DevOps so you have it. So let's make sure we have everything saved, because that would be very bad. So File, Save All. It's important. And go here and git add dot. Git commit -m, and we'll say tested seek successfully. For the most part. There's some minor things we have to tweak. So questions, please. This is your time to ask this stuff. You've got your first steering behavior. I know we worked hard on this one, believe it or not, because we did all these, we jumped through hoops. That's what it felt like doing to get everything done. But what we've done is we've put together a little foundation, is what we've done for future steering behaviors and future pathfinding, believe it or not. Because now we're able to march along the grid. The grid knows of our passing. It continues to update things throughout, the entire time, and we're able to test, different things there, and we can use that information for things like obstacle avoidance, path following, and a bunch of other stuff. Only part of which we're going to handle this semester, because we just don't have the time. But it gives you the tools you need if you wanted to make your own custom behavior, movement behavior, for your own game. You can do this exact same thing. Questions before we go for the day? If not, my friends, have a good weekend. Thank you so much for being flexible and going online today, and I apologize about being late. Just weather outside is nuts, at least up here in my area, or down here, I mean. And so, good luck with it. Please continue to work on your assignments. You have assignment 1 from each of the classes. So please don't, pause and say, well, it's a weekend, it's done. You got lots of work to do, and there's lots of stuff coming up. Remember, I'm going to move these due dates. You'll see them move, but please continue to work on them, especially if you're working alone, if you're a solo coder or something like that. There's lots of stuff to do, and please don't leave them until the last minute. Okay, guys, thank you so much, and I'll see you guys next week. Remember, next week we are remote, Wednesday and Thursday, and in person on Friday. All right, take care. Thanks a lot, Damon. Take care.